Hello friends, in this video we will discuss the geometric meaning of zeros of a polynomial. As you already know, a real number k is a zero of the polynomial px if p of k is equal to 0. Now, right now, we want to know the geometric meaning of zeros. So, if you try to find the definition, you will get that zeros of a polynomial px are the x coordinate of the points where the graph of y is equal to px intersects the x-axis. Let's try to understand this sentence with the help of a graph. Say this blue line is x dash axis, means x-axis. This green line is y dash axis, means y-axis, and this black line is a graph of a polynomial. Since this black line is a straight line, so obviously this will be of graph of a linear polynomial, and says that x coordinate of the point. So we need to focus only on the x coordinate, need not to focus on the y coordinate, where graph of y is equal to px intersects the x-axis. So can you see that this is the point where x-axis is being intersected by this graph, which is here in black color. So this point will be the zero of this polynomial. Similarly, if you look at this this parabolic curve, you find that this one is the point and another is the point, this one, where the graph is intersecting the x-axis. So for this parabola, you will have two zeros, this one and this one, and from graph you can easily say that this will be some positive value and this will be some negative value. Let's take some real example so that you can understand it easily. Let's take an example of linear polynomial. Say y is equal to 2x plus 3. So here polynomial is 2x plus 3, which is a linear polynomial. Okay, so what you will do, just make a table like this, x, and here y is equal to 2x plus 3, like this. Here what you will do, you will put some real value of x and find what will be, and try to find what will be the value of this expression. So take, say suppose -2. So when you will put -2 in this expression, what you will get, this will comes out to be 2 into -2 -4 plus 3, this comes out to be -1. Now takes x is equal to this time 2. So after putting 2 in place of x, you will get 2 into 2 4 plus 3 7. So since this is a linear polynomial, to draw the graph of a linear polynomial, you require at least 2 points. Okay, means 2 coordinate points. Since -2 and -1 are the one coordinate point and 2 and 7 are the another coordinate points for the graph, so you can now easily draw the graph of this linear polynomial. Let's try to draw it on graph paper. Say this one is the x-axis and this one is the y-axis, and each square is equal to 1 unit. Say 1, then 2, 3, 4, 5, 6, 7. Similarly here 1, 2, 3, 4, 5, 6, 7. Similarly, this side also -1, -2, -3, -4, -5, -6, -7. Similarly, this side -1, -2, -3, -4, and -5. Now let's try to plot these points -2 and -1, 2 and 7 on this graph. For x is equal to -2, you have y is equal to -1. So on the x-axis, you need to go -2 units from the origin. Since this is the origin, so go -2 unit here. Then in the y direction, -1 unit. So for -1 unit, you will need to go down. So -1 unit. So this will be your -2, -1 point. Then next point is 2, 7. So 2 is on x-axis. So from the origin, you need to move 2 unit in the x direction. So this is 2 unit in the x direction and 7 unit in the y direction. So this is the 7 here y. So this point will be 2, 7. Now you have this point and this point. As you know, to draw a straight line, you need at least 2 points. You have now these 2 points. You can join them to get a straight line. You find that you are getting a straight line. Since this is a linear polynomial and linear polynomial always gives you a straight line, and you also find that this line is intersecting the x-axis. This is the x-axis intersecting the x-axis at this point, which is somewhere in between -1 and -2. So can you tell me the point, a point just between -1 and -2? That obviously this will be equal to your -1.5. This will be midpoint of -1 and -2. Now let's try to find 0 of this polynomial with another method. As you know, to get 0 of a polynomial, you just have to equate this expression to 0. Means you need to write 2x plus 3 is equal to 0. Just equate it with 0. On solving, you will get this, that x is equal to -3 by 2, which is -1.5. So what you find actually, that when you plot a graph of a polynomial, the graph is intersecting on x-axis at some points. That intersecting point is the 0 of the polynomial. So what you understand from the geometric meaning of zeros of a polynomial, that whenever you plot the graph of the given polynomial, you will find some intersecting points on the x-axis with the graph, and that intersecting points will be zeros of the polynomial. But in some cases, it is quite often that you will not find any intersecting point. Then in that case, you will say that there is no 0, means there is no any point on the x-axis which can make the expression equal to 0. So in that case, you will have no 0 of the polynomial. Here one tip that I can give you, that to draw any curve, first you need to find values of x as well as the polynomial For that, what you do, take any random value which is very small and put that value in the expression and find the value. And you take one negative value of x and one positive value of x at least. And if you desire, you can take more than these two values also, but at least you try to take one negative value and one positive value for this linear case, means linear polynomial, not for other type of polynomial. And remember always to write the points which you have plotted. So here you have plotted the points -2 and -1. That point is here, so don't forget to mention this -2 comma -1 this way. Okay, similarly this point was 2 comma 7, so write here 2 comma 7. Now let's take an example of quadratic equation. Now let's take an example of quadratic polynomial. Say y is equal to x square minus 3x minus 4. So again we need to do same thing. Here make a table and write here x, here y is equal to x square minus 3x minus 4, and you need to pick some random value of x which should not be very large. It should be like 1 2 3 -2 -1 0, this type, so that you can easily calculate the value of y. So here I want to take first -2. So when x is equal to -2, the y value become 6. To get 6, you need to just replace the x value with -2 and solve the expression. You will get this 6 value. Then after that I will put -1, you will get 0. Then I will put 0, you will get -4. Then I will put 1, you will get -6. Then I will put 2, then you will get -6. Then I will put 3, you will get -4. Here I will put 4, you will get 0, and finally I will put 5, you will get points -2 6 -1 0 up to 5 6 on this graph. So let's draw first -2 and 6. So -2 is this one, and for that y value is 6, we need to go upward for positive value. So this is the point. This point is -2 and 6. Next point is -1 and 0. So -1 is this one, and 0. And you know, let me take first define the axis. This is x axis, so x dash. This is y axis. One thing remember that on the x axis, y is always 0, and on the y axis x is always 0. Remember this point. So for x is equal to -1, we have y is equal to 0. So x is -1 this point, but y we need to put 0. So as I just told you that on the x axis y is always 0, so next point will be our this one. Then we have to plot this 0 comma -4 point. So this is the 0, but I have to go -4 in the y, so that -4 will be this point. Next point is 1 minus 6. So from origin we need to go 1 unit in the x direction and minus 6 unit in the y direction. Then 2 minus 6, this is the 2 unit in the on the x-axis, then 6, this is the point. Then 3 minus 4, so again 3 is this point and minus 4, again you have to move down, this point will be 3 4. Then 4 0, so this is 4 and you know on the x-axis y is always 0, so this is 4 comma 0. Next is 5 6, so this is 5 on the x-axis and you need to go 6 unit in the y direction, that point will be this one. This time since you have taken a quadratic polynomial, so only 2 points may not be sufficient to draw the graph. That's why we have to calculate this number of points to plot a smooth graph. And another thing that I want to tell you, that these numbers 1 2 3 4 5 6 7 8 9 10 and similarly this and up to 7 and here minus 1 minus up to 6, this number can be plotted or can be drawn in such a way that all these points that you have calculated can be fit within the range. Say here I have taken 10, here minus 1. You can also take, since you see here maximum value of x is 5 and similarly for y you have 6 maximum value. So if you even do not plot this 7 8 9 10, here also minus 8 minus 9 minus 10 minus 11, you can easily plot your points on the graph. So these numbers can be adjusted as per these obtained points. So now we have got enough points, so let's try to join them. Okay, so this point and this point need to be joined, so let's try to join. Though it's not a smooth graph, but you can make your own self. So again, don't forget to mention the points you have plotted. So this point was minus 2 comma 6, this point was minus 1 comma 0, and this point was 0 comma minus 4, this point was 1 minus 6, and this point was 2 minus 6, and this point was 4 comma 0, and finally this point was 5 comma 6. So this time you find a graph like this bell shape. Okay, so this type of graph shape is called parabola. Remember this. For a quadratic polynomial, you will always get this type of, either this type or the inverted bell. Inverted bell means, I say this is like open, its face is opening upward. In the other case, maybe that face is opening downward. So this type of graph is called parabola. And again you find here that this parabola is intersecting the x-axis. One is this point and the another is this point. So we need to only focus on the x-axis. You see here it is also intersecting this point, but this is not of our point of interest because this is y-axis. So only focus on x-axis to find the zeros of a polynomial. So this point will be zeros of a polynomial because you can already, since you have already calculated that at x is equal to minus 1, what you are getting, the polynomial value you are getting 0, and at x is equal to 4 the polynomial value again you are getting 0. That's why this -1 and 4 are the zeros of this quadratic polynomial. Based on this, on the shape of this parabola, you may have two shapes. First one say like this one, and second one is like this one. Okay, so you say this one is open upward and this one is open downward. And you can also say that this is a smiley face and this is a non-smiley face. Since you know a quadratic polynomial have a standard form like this, ax square plus bx plus c, where a can't be 0. So this open upward parabola will you get when this a means coefficient of x square is positive, means greater than 0, and this downward opening type paragraph will get when a is less than 0, means negative. So whether a parabola will open upward or downward, that will be decided by the coefficient of x square. If the coefficient of x square is positive, then the graph will look like this. If the coefficient of x square is negative, then the graph will look like this. This is very important, so just remember it. Now you come across the shape of a quadratic polynomial. So based on the shape, there may be three cases. First case may be graph cuts x-axis at two distinct points a and b. So ax square plus bx plus c, where a can't be 0. This is the standard form of a quadratic polynomial. So the graph, suppose a is positive for first case, then graph will look like somewhat this type. Next, there may be like that a is negative, means this coefficient x square coefficient is negative, then in that case you will have this type graph. And you also observe that this is the point where the graph is intersecting. Let me give its name a, here b. Similarly, this graph is also intersecting x-axis a, this is point b. So here I have not given the axis name, so write the name of axis also. What you can confirm now, that when a graph cuts x-axis at two distinct points, then in that case you will have number of zeros will be equal to 2. So this is the conclusion that you can find from this one. Next case, maybe that graph cuts x-axis exactly 1 points a, that is at two coincident points. Again I am writing the standard form of a quadratic equation, ax square plus bx plus c, where a can't be 0. So graph cuts x-axis exactly 1 point. So this may happen when both the 0 of this polynomial may be become equal, means 2 points are coinciding or overlapping. Then in that case you will find only 1 points is intersecting at x-axis. That case may be like again this type for a greater than 0, means a is positive. This is for a is negative. what you find here actually is it is intersecting at this point only. So this is a single point. This is because both the zeros are same, so that's why the points are overlapping or coinciding. Similarly, in this case, you are getting only this point. So what you can confirm here, that when for a quadratic polynomial graph cuts x-axis exactly 1 points, then number of zeros is equal to 1. The next case, maybe graph is completely above x-axis or completely below x-axis. There is also possibility that the graph is completely above x-axis or below x-axis. So in this case, you will find that there is no point of intersection of this graph and x-axis. Also, in this case, you will find that there is no intersection points on the x-axis. Again, I have not given here name, so write name here of the axis. So in this case, you can confirm that when a graph is completely above x-axis or completely below x-axis, number of 0 is equal to 0. And again, this open upward curve will happen for ax square plus bx plus c, where a can't be 0. This a coefficient of x square, when positive, then this open upward curve you will get, and this case when a is negative. So geometrically you can say that a quadratic polynomial may have either two distinct zeros or only one zero or no zero. You can also take a note that you know that a quadratic polynomial is of degree 2, so a quadratic polynomial can have two zeros at most. This is because number of zeros depends on degree of polynomial, and more precisely you can write here maximum number of zeros depends on degree of polynomial. Say quadratic polynomial you know have degree 2, so its maximum number of zeros can be 2. Similarly for linear polynomial, you know its degree is 1, so maximum number of zeros for a linear polynomial may be 1. Now let's take an example of cubic polynomial y is equal to x cube minus 4x. So first we need to take some at random value of x, and at random value we need to calculate the value of polynomial. So let's say take x is equal to minus 2. So when you will put x is equal to minus 2 in this expression, you will get 0. Next take x is equal to 1. Then the polynomial value will come out 3. When you put x is equal to 0, then this becomes also 0. When you put x is equal to 1, this comes out to be minus 3. And when you put x is equal to 2, then y is equal to 0. So again, we need to plot these points on this graph, and then only we can draw the smooth curve. So let's try to draw the curve. So where first point is minus 2 0, so x is minus 2, so this is x is minus 2, but y is 0. As I have already told you, on x-axis y is always 0, and on y-axis x is always 0. So this will be our first point. Next point is minus 1 3. So in the minus x direction, this is minus 1 and 3. Since 3 is positive, so need to move upward. This point will be 1, minus 1 and 3. Next point is 0 0, so this is our next point. And 1 and minus 3 next point, so 1 in the x direction and minus 3 in the y direction, so this is point. Then next is 2 0, so 2 in the x direction and 0 means this is the point. So you find that some points like this one, this one, this one, and this one. So when you have even large number of points and try to join them, you will find that the curve is somewhat this. And don't forget to write the coordinates of points that you have plotted. So here you can see that the graph of the polynomial is intersecting x-axis at 3 points. This is the first one, this is the second one, and this is the third one. So you can conclude that there will be 3 number of zeros for the given polynomial. And now you can say number of zeros is equal to 3. Why 3? Since a cubic polynomial is of degree 3, so maximum number of zeros can be 3. Also the number of zeros can be even less than 3, but maximum number of zeros will remain 3. Let's have a look on another polynomial. Say y is equal to x cube, and second is y is equal to x cube minus x square. This time I will use my graph plotter for plotting both the curve. The reason behind using this graph plotter is that I want to show you the very accurate result. The very first polynomial is x cube, so I will put here x cube, and just clicking display, you find that the graph is, if I am moving this small point over the curve, you are also getting the coordinate points. But one thing here you can find that the curve is intersecting the x-axis. Let me see you the x-axis. This is the x-axis, this one is the x-axis, and this one is the y-axis. So what you are finding here is that the curve is only intersecting the x-axis at only one point. So you can say that since you have just now studied that a cubic polynomial can have maximum 3 zeros, but it can also have less than 3 zeros. For this case, what you have, number of 0 is equal to 1, because the graph is intersecting the x-axis at only one point. Why this is happening? Because the other two roots are also overlapping or coinciding with on the same points. That's why it has only one root. Now let's try to plot this time this function y is equal to x cube minus x square. Now here I will define x cube minus x square. Yeah, this pink one, or whatever the color you say, red one, this is the graph of this y is equal to x cube minus x square. Again you see that the graph is intersecting the x-axis at 2 points. This one point is at near about 1 and second is at near 0. So again you can say that here number of 0 is equal to 2. So why number of 0 is 2? Because there is also another 0 which is coinciding with the other 0, means both are same. That's why you are getting only 2 zeros. And from the examples that I have taken, we see that there are at most 3 zeros for any cubic polynomial, or in other words you can say that any polynomial of degree 3 can have at most 3 zeros. And also one tip that I want to give you, that for a given polynomial px of degree n, the graph of the polynomial px intersects the x-axis at most n points. So a polynomial px of degree n has at most n zeros. Thanks for watching.